You probably have learned a number of ways to search for an item within a data set. For example, you could try linear search. And linear search gives you an order of n worst case complexity. And if your data set is already sorted, you can try binary search. Binary search is much more efficient. It gives you an order of log n worst case complexity. So the question is, can we actually do better than that? Search is very important operation in computing, and we're hoping for an order of constant search, at least for the average case. And that's the promise of hashing. Hashing attempts to give you an order of constant search on average. So let's see how that works. So in order to do hashing, we allocate an array of buckets to store our data elements. In this example, I have 10 buckets indexed from 0 to 9. And we maintain a hash function. A very common hash function is called mod hash function, where h of x equals x mod the size of the array, which is in this case 10. Now to do insertions into this hash table, so let's do insertions. What we need to do is just compute this hash function. So let's say we want to insert 52. We compute h of 52. That is 52 mod 10. The remainder of division of 52 by 10, that is just 2. And then we go to the bucket number 2 and insert our data item right there. Let's say I want to insert 30. Again, I do the same exact thing. I just compute the hash function 30 mod 10, that is 0. So I go to bucket number 0 and insert 30 right there. Now, let's say I have inserted a bunch of numbers and now I want to search, right? I want to find out if 52 exists in my data set. So to do that, I basically do the same process. So I need to compute the hash function for 52. So 52, h of 52 is again 52 mod 10, which is just 2. So I go to bucket number 2, 52 exists there, so I just declare that it's found. Let's say I want to search for 35, so h of 35, do the hash function computation, so that's 35 mod 10, which is 5. Now I go to bucket number 5, 35 is not there, so I declare it not found. So that's the basic scheme of hashing. Now let's see the complexity of these operations. So for insertions, all what we're doing is just doing some computations, right? And following this computation, we're just storing the data element. So that is an order of constant operation. Same thing for the search. All what we're doing is just doing a computation and then doing a comparison. So that's again order of constant operation. So there you go, a very efficient search, order of constant in this case. However, there is a serious problem here, which is potential collisions. So let's take a look at that. Now let's say my data elements are just integers. So I want to store, using the same hash function, h of x equal x mod 10. I want to insert 13. So h of 13 equals 13 mod 10, which is basically 3. So I go to bucket number 3 and insert 13. It's not there. There's nothing there, so I can just insert 13. Now let's say next I have 23 that needs to be inserted. So 23 mod 10, that is again 3. Now bucket number 3 is already occupied, so I cannot insert it here. So there is a collision. Now, much of the discussion beyond this point about hashing has to do with strategies to solve this collision, to resolve these collisions.